2, which is going to be the estimation and interpreting of graphs. So you're going to see these problems in the Alex lab. They're going to be related to getting an interpretation and or making some observations. So estimation is the process of finding an approximate answer. It's not an exact answer, but it's very close. The process of estimating typically uses rounding, which is the application of place value. So when we're teaching elementary mathematics, we teach a lot about place value of a digit, and students know the ones from the tens from the 100ths place. So for example, if I have 325, the 3 means 300ths, then I have the 2, which means 2 tens, and the 5, which means 5 ones. So I get 325. To round numbers, we want to use these rules. I want to locate the place value that I need to round to. If you need a refresher, here's a refresher on place value. So if you notice this is not an error on your computer screen, that is a decimal point. So that's why we have tenths, hundredths, thousands. So remember, after the decimal, it doesn't go to tens or ones, it goes to tenths with a TH. Once I know the place value that I'm going to round to, then I can look at the digit. If the digit is 0 to 4, I don't change the place value digit. If the digit is 5 to 9, I'm going to add 1. When I round whole numbers, I replace all digits to the right with zeros. So if I have 15, I'm going to add 1 to get 20. And so that 5 becomes a 0. So that's what I'm talking about. So here's an example. If I have $147.38, I want to round that to the nearest $10. That means the tens place, which is where the 4 is. So I have $150 because everything else becomes a 0. And 7 is greater than 5. According to Wikipedia, people's nails grow at 0.1181. So that's above average. I'm going to round that to the nearest hundredth, which is behind the decimal. So I have the tens place and the hundredths place, which is a 1. And as I'm rounding that 1, I'm going to look at the number behind it. Is 8, 5, or greater? And the answer is yes. So that would be 0.12. As of December 11th, I've got a candidate in the presidential election. I want to round it to the nearest million. Well, the 5 is in the millions place. The number to the right of it is 4, so it's just going to stay the same at 65 million. So those are all really strong examples, and this is just walking you through what I just said. So the key here is to make sure that you're understanding the place value of the digit that we want to round. And so, kindergarten, first grade teachers, they spend a lot of time teaching place value, and it's not always apparent to students why they have to learn place value. Well, because when we get to estimation, it's really important that students understand what it means so they can round proficiently. So when we use estimation, we're trying to simplify calculations. So I want to round the numbers, and then I want to perform an operation. That's what's the difference between estimating and just plain old rounding. So if I have this example and I've got 6 new refrigerators, I choose a model that's $579.99. They want me to estimate the total cost of all 6 and then decide if it's an overestimate or an underestimate. So the way I would do this is I would say, well, 579 is close to 600. Notice that I'm rounding up. That's going to be important. 600 times 6 is 3,600. So I've done my operation. Now I have an estimate. Since I rounded up, it will be an overestimate. It's that simple. If I rounded down, it would be an underestimate. So looking at a different example, this time I'm looking at a cell phone plan where I have to pay $179 up front for the latest phone. But the monthly charge has $39.99, and that gives me a lot of extra benefits. So I want to estimate the cost for 1 year if I have no additional charges. Well, I can say, well, that's really close to $180, and I could round to 40 just so I don't have to deal with decimals. And so I'm going to say, okay, the monthly cost, I'm going to take that and multiply it by 12. That's $480. Then I have to add in that additional yearly cost of the phone. So that'd be $480 plus $180. So roughly that's $660 for 1 year. Now, I rounded up to 40. I rounded up to 180. So it's going to be an overestimate, which is what we want to do when we budget, because it's better to overestimate your expenses than to underestimate them. Here's another example. So in this example, I'm working with 21 square yards of carpet at $23 per square, and they'd like to keep the cost around $1,000. Again, I'm estimating a cost, so I want to round up. So let's say $23 rounds up to 25. 21 square yards, I could round down to 20, which is roughly $500. $500 divided by 25 is $20. So they should be looking for wallpaper that costs no more than $20 so they can stay under their budget, because they have to get the carpet and the wallpaper. Now, we're going to leave estimation behind and talk a little bit about graphs. A bar graph is a graph that's used to compare amounts or percentages using either vertical or horizontal bars. Most of you are going to teach vertical bars to your students, so we rarely ever teach horizontal bars at the lower grade levels. What's nice about these bars is, especially in this graph right here, I can glance at this and say, whoa, blue is male and blue is taller than orange. So I know that whatever I'm measuring, males have more of it. And this is suicide rates. And so, yep, it's that's the fact of the statistic. So bar graphs are very visual, and they give us visual information in a way that we can just glance at it and know. So this is the actual long explanation for what I just said. A pie chart is different. So a pie chart, I'm not comparing heights, but it's also a visual measure, and it's typically using a percentage. So pie charts are primarily percentage based, and it should make sense that 58% is slightly more than half the circle. And so when I look at this image, I say, wow, whatever is 58%, that's the majority of what I'm measuring. So pie charts are also a great visual way to depict information. So if I look at these fatal occupational injuries, I can see transportation right off the bat is the majority of the circle. And then assaults and falls are actually kind of even, and fires are very rare. So this is a very visual way of getting that data out of the graph. A time series graph is going to be less used in the classroom at the lower grade levels, but it's anytime I'm representing something over a time period. So this is most often what's in the newspapers. So we're plotting inflation. We're plotting approval ratings for politicians. We're plotting profit. Anything that's related to time could be used with the line graph. So if I look at the two line graphs to the right, they each illustrate the number of Americans that are living in poverty according to the federal guidelines. So it's over time. I can see from 1985 to 2020 who all is living in poverty. If I want to find the approximate number of Americans living in poverty during that time, I'm going to find the year 2015 on the horizontal axis and go straight up until I hit the graph. So 2015, straight up till I hit the graph, and that's going to be roughly 43.5 million. Now for part B, I want to look at 1995, and that's almost half between 36 and 38. So 1995, it's between 35 and 40, right? When you look at this, let me see if I can enlarge this a little bit. So I have to estimate it. And guess what? Any estimate is good between 35 and 40. You don't have to have the most right estimate. If I'm looking at C, then we're given the number of people, which is the height of the graph, and we're asked to find the corresponding year. So in part C, it wants to know, estimate the year where Americans living in poverty first topped 40 million. So I'm going to people in poverty, and it first topped 40 million, and that looks like roundabouts here. And so if I look at the answer to that, it's going to be after 2005. It's fairly close though, so I would say 2006, 2007. There is leeway built into ALEKS, So don't spend time stressing over if it's exactly 2006 or exactly 2007. Make sure that you give yourself some grace there.